Welcome to the final review video for logarithmic equations. This is the last of the 6 review videos. Log equations were the last ones you learned. Hopefully they're pretty fresh in your mind. Of course, a logarithm equation isn't just any equation where you use a log. It's specifically where the variable is inside the argument of a logarithm. Basic vocabulary you will need to use is base, argument, and this number can be called the answer or the outside number. Either one works for me. Clearly, you'll use the word logarithm. If the goal is to get x by itself, we need to somehow take it out of the log. We can't just cancel that log out magically. In order to get this out, we use this trick of rearranging a logarithm, and we make an exponential equation. This is an exponential, not really an exponential equation because it's a number up here, but it's exponential format where the argument of the logarithm is actually the answer. This is now very easy to get x by itself. Take a moment to make sure you understand all the pieces that switched, and the rest of the math should be pretty easy. Sometimes you may need to isolate as your first step. Remember that you always get rid of a constant before you get rid of a coefficient. Don't divide 3 first. Subtract the 7 first. And you'll end up with something like this. Now this is pretty weird because we have an answer of 8 over 3. That's okay. You still know how to rearrange it, and ultimately 3 to the 8 over 3 is your answer. And you can put this in a calculator in decimal form. So 8 divided by 3 is going to be about 2.666. So if we do 3 to the 2.66 power, you should see that you have an answer of 18.584. Pause the video here and work out the first 2 practice problems. When you press play, I'll show you the answers. There's number 1 and number 2. Alright, let's keep moving. Next logarithmic equation is going to use, again, one of your very favorite numbers. The trick to doing a logarithm with a natural log, this ln, is you need to really remember what that ln means. Sure enough, the first step is going to be to isolate it, because this is a log equation because the variable is inside the logarithm. Our goal is to get a number for x that we could plug in so that both sides equal each other. In order to get that x by itself, we'll isolate first by adding 3. And then remember that ln is the same thing as log base e. That's just a different way of writing that. So this whole expression could be written as log base e of x equals 8. In this case, I know how to rearrange this. I've got 3 pieces. They get flipped around a little bit. The base comes down, 8 becomes the exponent, and then x goes by itself. In this case, this is another thing that you can do in your calculator. In order to find the number, you need to press 8 first, and then we're trying to do e to the 8th power. If you look in green up here, there's a button that looks pretty similar to what you are actually doing. So if you press 8 first, then second e to the x, the calculator does that calculation for you. You should notice this is a huge number, 2,980.957. It's a very big number because you're multiplying something by itself 8 times. That makes sense. That sounds like the right answer. X equals 2,980.957. Of course, you could check that answer by plugging it right back in here. If I were going to plug this number here, I would use a different button on the calculator. That's when you use the ln button. If I wanted to check and evaluate ln of 2980, I would just put 2980 in the calculator and hit ln. I would get something pretty close to 8, and 8 minus 3 equals 5 on both sides. This is where you use the ln button. This is where you use second to get the e to the x. Take a look at your example. In this case, your final number should be 7.389. The next example problem is actually another super lucky one. If you have a logarithm on both sides with the same base, that's important. The truth is that this argument must equal this argument. So really this is just a linear problem. It's not anything difficult. And in fact, this works just fine for natural logs too. Try the one on the right. This is what the answer would look like. Again, I could just bring them down because the logarithms have the same base. What's the base, by the way? That's right. E is the base for these logarithms. You may not see it, but you assume it's there. Okay. The last problem is going to test you a little bit on your log properties. Before you can switch anything to exponential form, before you can get x by itself, you would want to combine these logarithms or evaluate this as a decimal. Either way should give you the right answer. I chose to combine them. And I remembered that subtracting two logarithms with the same base is kind of like dividing x divided by 4. If log base 3 of x over 4 equals 2, I'm just simplifying, that must mean that 3 squared equals x over 4. And that's where I change it to exponential form, because I'm trying to get x out of the argument. From here, 3 squared is 9. Sorry about that. And then we cross multiply, and x must equal 36. There's your final answer. If you work out the one on the side, this is your final problem.